Alrighty, so I guess the longest unequal adjacent group subsequence 1 is followed by the 2 version, medium. You're given a string array words and integer groups of length n, and the Hamming distance between two strings of equal length is the number of positions at which the corresponding characters are different. The number of positions at which the okay. You need to select the longest subsequence from an array of indices such that the subsequence denoted having length k, the following holds for adjacent indices in the subsequence. Their corresponding groups are unequal. Okay, words of I and words of I plus words at I sub j and words at I sub j plus 1 are equal in length, and the Hamming distance between them is 1. Turn a string array contain the words corresponding to the indices in order of the selected subsequence. There are multiple answers. Return any of them. Words may be unequal in length. So if the words are BAB, DAB, and CAB, groups are 1, 2, 2. The subsequence can be selected 0 to 2. What is going on here? Select the longest subsequence from an array of indices such that the longest. So adjacent indices in the subsequence. For adjacent indices in the subsequence, their corresponding groups are unequal. The corresponding groups are unequal. And words at I and words at I sub j and words at I sub j plus 1 are equal in length. Hamming distance between them is 1. So Hamming distance is there's one character difference basically between the words. The subset can be selected 0 to 2, so I think 0 to 2. Groups at 0 does not equal groups at 2. Okay, so like 1 is not equal to 2. Words at 0 dot length and words, so these two are the same length and their distance between them is 1 because the B and the C is the only thing that differs. You could also have selected 0, 1. Need to select the longest subsequence. So 0 and 1 would work, where 0, 1 is groups 1 and 2. So groups. So the answer is a subsequence where the value here, if I use these as the indices within groups, the value of groups at those indices cannot be the same, and the words at those indices have to have a distance of 1 apart. Okay. So we can do 0, 1, 2, 3, 4 because the groups at those indices are all different. And words at 0, words at 1 Longest subsequence in Z that satisfies the condition. They all have a distance that's 1 away. Words I and words I sub j. Okay. Okay. I think I get it. So the distance between consecutive words needs to be 1 apart. So you could have something that's like bab, dab, and damn. Because damn and dab are 1 apart, but so you can basically change a character. Words consist of distinct strings. It can be of length up to 1,000. The longest turn a string array containing words. Interesting. Okay. So the test case here to check what my thinking is that my thinking here is correct. So if I said this is 1, 2, 3, and it's actually bab, dab, and damn, I think the result should be 1, 1, 2, 3. Or yeah, so it should be all 3. If the groups here was 1, 2, 2, then it should still be just 2 words in the expected solution, because the groups are not the same. Okay. So how to go about this? So I think the first thing that makes sense is to order things by the groups. Because you can't, so basically a group, you think of the branching, you can only branch to one of the 2 2s. If I think of this as a chain, like bab to dab, you can only change bab to dab or bab to dam. You can only change the things that, so only one of the 2 is going to be ever used in the chain. So the question is, what's the best chain? Also make a graph for each word. What's the words that are 1 apart? Does the order matter though? Can I go like first to third to second word? The longest subsequence. So I don't think I can go backwards. I can't go like, so like the first word and then the last word and the middle word. Can't do that sort of jumping. So any word can only jump to something else afterwards. Interesting. Do groups increase in value as well or no? They don't necessarily. Interesting, interesting. So if I sort by groups, it doesn't necessarily help. Well, it doesn't necessarily help because you still need to have the longest subsequence where the sequencing matters of the original pre-sorted. Yeah, for adjacent indices in the subsequence, their corresponding groups are unequal. Oh, adjacent indices. Oh, interesting. So I could go, this was 1, 2, 1. This would actually be all 3, I think. So you just can't repeat. You just can't repeat. Okay. It's not like you can't repeat the same groups within the sequence, it's just you can't repeat it consecutively. Interesting. That makes it a little easier, I think. Because then you only track the last group and then see if the word attaches to that. This should be a one-pass solution. Should be a one-pass solution. So now would I do it in one pass? Would I do it in one pass? Is it possible for me to detect the Hamming distance one away? Actually, let me double check here. So the size of the words is 1,000, or the length of the words is 1,000. So I could get away with an n squared probably, comparing every word to every other word to see if they're one distance away to make the graph basically. Can I do it in a pass? Can I determine which words are connected without necessarily doing a comparison between every single word to each other word? Bab dab damn. Bab dab damn. So like in a single pass, can I detect that bab and dab are connected? Dab and damn are connected. And like every other connection doesn't exist. Bab doesn't connect with damn. Don't think I can. Or what if it's sorted? If I sort, it would do n log n. Can I detect it using a sorted version? Not really. I don't think, because sorted just doesn't necessarily guarantee that two things that are very similar are adjacent in the sorted array. Like the first letter could be different and then they're really far apart in the sorted array and they're still connected by one. Okay, so I'm gonna try just doing it. So I'll have a graph which is let's say it's right now it's just a default dictionary of list, and that'll be the connection between each word and connected words maybe. So for every index in range n, and then for every other index to say index 1 in range n, index 2 in range n as well, or range index. Can I do it for every one later? Yeah, for every starting index, and then for every other later index. So it's, yeah. Start later, start index, for every word index, and for every later word index in range word index plus 1 to n. So detect Hamming distance 1. So it's spelled Hamming, H-A, yeah, Hamming, okay. So how would you quickly detect that? So it needs to be the same length. If the length of, let's say, word 1 and say word is the words at this word index, and the other is the words at this later index, and if the length of word not equal to the length of other, then skip. Needs to be one apart. Needs to be one apart. I guess I just have to go diff is 0 for every letter index in range of the length of word if the letter index, if the word at this letter index not equal to the other word at this index, diff plus equals 1. If the difference is greater than 1, then break. If diff equals 1, then the Hamming distance is 1. So graph at this word appends this other word. I might need to keep track of the index as well. It could maybe also be a set. Can the words be repeated? Or are these uniqueness words? Words are all distinct. Okay. Okay. So I have for each word the words that are related to it. Let's go and just print out the graph. Make sure that that's working. So Bab is connected to Dab, Dab is connected to Dam, Bab is connected to Dab and Cab, and Dab is connected to Cab. Okay, that's fine. Okay. So okay. So for every So for each word, okay. What I think I can do is say that, let's say I have a chain array that is of length n, and it denotes the longest chain up to for each word. I think actually I need to do one other thing. I can't actually have a word that has the same group. So even if the Hamming distance is 1, they need to be of different groups in order to chain at all. If the length of the words is different, or the groups of the words is the same, groups of this index is equal to the groups at the other index, then skip it. Yeah. Okay, so from I wonder if I can do this in one pass then. Do this in one pass. Well, I guess it doesn't even. I guess it wouldn't be one pass because of this thing here. I'll separate out to 2 separate for loops, but I think this next for loop could be done within the initial for loop. But in any case, it's going to be for every index in range n, and let's say the current chain for this. The current chain for this is going to equal chain at this index, and then for every later word, I'm going to say that later word could be connected to this word's chain if it's bigger. So actually maybe I need to append not the later word but the later word's index, because that's more useful. So for every other index, so for every other, say, later index in the graph of this word, maybe I shouldn't be using graph of the word, graph of this index. Yeah, I'll use graph of this index. For every later index in the graph of this index, if the current chain plus 1 is greater than chain at that later index. I guess I could just say max. Yeah. Then chain at this later index is equal to the current chain plus 1. Because there could be another way of getting to that later one that's way longer in theory. And then, oh shit, they'd want me to actually know what the longest chain is. Look, they want me to actually know the longest chain. I need to keep track of the longest chain rather than just the length of it. I need to keep track of what boards for part of the chain. That might be a really long thing to keep track of. How to keep track of. What if I kept, instead of just a single number for the length of the chain, kept track of a number and the previous previous index? Yeah, maybe keeping track of a tuple. So current chain is going to be 1. So let's say the chain is 1 negative 1 times n. Let's say this is returning 0. Print out this. I don't know if this actually works. Okay, I think it does. I think it would. 1 negative 1. Other index not defined. Yeah, later index. Later. I should probably be consistent using either other or later. Graph. Whoops, this should be word index. Okay, yeah, 1 negative 1 is what I have here. So the current chain and the previous index is stored at chain index. For every later index in the graph of this index, if the current chain plus 1 is greater than the chain at the later index, the 0 element of that tuple, then chain at the later index, it's going to be a tuple that is the current chain plus 1 as the length, and this index as the previous index. Okay. And then let's say let's get the longest long chain length is going to be the max of chain. And long chain length and last index is the max of chain. print out the max chain. See if that code does what I think it should do. Longest chain length is 3. That's not correct. Actually, that is correct. 3, 1. 3 is the length of the longest chain. The last element is here, but the element prior to this index is here. Is 1, then that one goes to 0. I actually need to know where the last one is, though. Okay, I just need to know where it is. So how do I find where it is? How do I find where it is? I could go to where the last index is, and this is going to be the second to last index, and then I look at the graph of that, and any of the things in that graph should work, because it's all going to be one. Okay, so I think that's fine. So answer is going to be an array, and let's say answer indices is going to be an array where the last index is going to be okay. So let's here. If the longest chain is actually 1, then that's going to be a trivial case, and I need to do that separately. If the long chain long chain length is equal to 1, then just return words at 0 in an array. Otherwise, I'm going to look at the graph. Answer indices is going to look at the graph of the last. Shit, it's in the wrong order. Answer indices is going to look at the graph of the last index and the first element of it, and the first element is a tuple. Is it a tuple graph? No, it's a list. So the first element should be any connection to it. So I could do answer indices of that, and I can do actually let's say end is graph of last index of 0. Answer indices is equal to an empty array, and then I say while the end is not equal to -1, then answer indices dot append the ending index, and the ending index is equal to the next ending index, which is going to be the one before that, which is going to be chain at this what? I need to use this as the index. Chain at end chain end. That's a tuple 1. Print the answer indices. Let's see if that works. Graph last index at 0. Excellent. 210. 3210. Excellent. And 10. Okay, so this is reverse order, but I can do. Then my answer is actually going to be for every index in the reverse index in range of n, answer.append words at the reverse index, so n minus 1 minus index. So the first thing here is going to be if index is 0. Yeah, I think that's right. Return the answer. Why didn't that work? I still have it reversed. What the fuck is wrong? Whoa. Not only do I have it reversed, this is too long. Index in range and whoops. Index in range. The length of my answer indices. Words. I'm gonna use my answer index. What the fuck? Words at just need to go through my answer indices backwards and get the words from it. Shouldn't be that hard. So if I go through my answer indices backwards, okay. I'll say the word index is the word is equal to answer indices. So the chain length is the long chain length is what I should be using for the answer indices deal. So the length of the answer indices is the long chain length. So for next, so answer indices of long chain length minus 1 minus index. No, it's still, this is the word index itself, and then using words at this index. Chain print. Let's comment that out. Alright, let's see if this is up to snuff in terms of overall speed. N squared. Should it be faster? Yay! Fast enough. Okay. So, time to spruce up the formatting here. Okay. Alright, so what did I do here? So this part right here is to determine for each word what later word is connected, can connect to it to form a streak. The two conditions being same, require same word length and Hamming distance equal to 1. Require. So for every word index in the range of n, word at this index, and then for every, let's say, other index, sure, every other index in range, word index should be in range word index plus 1. And then the other word is the word at this other index. And detecting impossible connections. So if they're not the same length or requires same word distance, same word distance, different groups, and Hamming distance equal. So this is where I just say if it's not the same length, because word length or grouping. So just skip that word if it's not same length or different groupings. And then this is the diff counter, count of character differences. Character differences between word and other, and then going through every letter index in the word. If the letter at this word and the letter at the other word at this index is not the same, then the difference is 1. Incremented. If the difference is too much, then just stop. After loop, if the difference is 1, then append. So this is note that tracking through indices rather than words. So here, for that word index, the later word index, the other word index that it connects to is added onto the list. And this is the chain, and this is for each index, the longest chain and previous index in that chain, but assume to start each word forms a chain of 1 with no prior word index. So that's that. And then for every index in range n, the current chain and previous index is that thing inside chain. And then for every later index that's connected, if the current chain plus 1 is longer than the chain that I see at that later one, then the chain at the later index becomes the extended by 1, and then using this index as the prior index. Yep. And then so this for loop is see if you can extend if the current chain extent plus 1 is longer than, see if current index word can form a longer chain to every later word that it connects to in the graph. And then once you have that, look at your maximum value pair in your chain array. If the chain is 1, the longest chain is 1, then you can just, this is kind of the trivial case, or special case if no chain exists. Return single word array. And then otherwise create longest chain array by first determining indices of chain, and this is going to the very last index. So the last index, actually I don't know where the last index of the chain should be. This is just the last, this is kind of the prior to last index, so this is determining and is initially anything connected to last index in the graph. So anything connected to it could be used as the last one, and then I append everything prior to that along the chain, and then I go and create the words, find corresponding words. I wonder if I should make this, yeah, whatever, 2 indices, and technically backwards. Alright, so summary is there's one, create some graph to determine which words / indices are connected. Again, they need to have same length, same word length, different groups, and Hamming distance is 1. Here I used a default dictionary of lists where word index is stored as key and lists, and value is the list of later indices that connect to that whose word connects to that word, and then to create an array that links words to later words if the chain they create is longer. This is using a nested for loop. Nested for loop. Outer loop is any possible start. Outer loop is every index. Inner loop is words that are connected to it. And then use longest chain from array to create the to find the actual array of indices, and then for is convert the array of indices into an answer array of words. And that's, so this is step 1 for the graph, step 2 for the chaining, step 3 for the answer array of indices, step 4 for the answer words. Time complexity, this is going to be O of n squared. Since the initial graph construction requires comparison of each word in array to every other word to see if they are connected. And that's the longest part by far. And then space complexity, this is going to be O of n. Since arrays are needed, O of n for the chain arrays, but then how big is the graph? O of n for chain array and O of n plus e. The graph has size of n times e, where e is the average, actually n times c, where c is the average number of connections from one word to a later word. So if you have a very random set of words that all have no kind of connections, then it'd be O of n for your default dictionary. But then if you have a bunch of, I don't know, 3-letter words that are all kind of one apart somehow, then you're pretty much doing that n squared kind of. Well, not n squared, n times the length of the word.